So let's take a look at a couple of real quick examples here of divergence. Let's find the divergence of f, this vector field, if f of x, y, z is defined as negative y, x, z. Well, the divergence of f is simply defined as the del operator dot f, which is the partial with respect to x of, in this case, negative y, plus the partial with respect to y, in this case of x, plus the partial with respect to z, of this case of z. So this is going to be 0 plus 0 plus 1. Therefore, the divergence is 1. Now, if actually, let's talk about this positive value 1. This positive value 1 tells me that the tendency is at that specific point, some point x, y, z, is to flow away. So the tendency is to flow away from this point. If divergence is less than 0, in other words negative, then the tendency is to, let's say, flow into the point. It's supposed to be an is. So let's take a look at another quick example. Let's go ahead and find the divergence if f is being defined as, how about x, z, x, y, z, negative y squared. So the divergence of f equals del dot f, which is the partial with respect to x of xz plus the partial with respect to y of xyz plus the partial with respect to z of negative y squared. We'll see that's going to be z plus xz plus 0. So I'll probably write this as z times 1 plus x. So unlike this first example, where the divergence was actually a constant, here the divergence is actually a function of either of x or z. So if our domain is only, say, in quadrant 1, or I'm sorry, the first octant in 3 space, so x, y, and z are all positive, then the flow, this would indicate that the flow is positive away. If we're talking about all of 3 space, in that case, for x positive and z negative, I'd have a situation where the flow would be inward. And then for z positive, but say a negative x less than negative 1, then this is going to be negative. So again, I'm going to have flow inward. For z negative and x less than negative 1, I have a negative times a negative. Again, I'll have a positive, so the flow would be outward. So this would actually represent flow in different directions depending on where in 3 space I was in this particular vector field. So here, in short, the value of the divergence is point dependent. It depends on where you are in the vector field. Whereas on this first one, the value of the divergence was a constant. It didn't matter where you were. It was always outward flow of 1.